we stop at this applications of the fringe sections where we want to know how flat of the surface, how good. It depends on the fringe design. Okay, so we have a three criteria that we must comply in order to make sure that the surface are in a good conditions in terms of a flatness. So the first one is a straight. The fringe must be a straight and then parallel each other, and also last one is a equidistant. So that is a three criteria that must be complied for the criteria, whatever criteria that we will evaluate or want to know the flatness of the surface. Sometimes if they have a curve like this, if you put the optical flat at the top of the curve section, so only the contact we will see the fringe or free from the fringe, and then if they have a gap between the optical flat and also the surface, it will come up with the various type of fringe pattern. So that is an example that I will show you. So like this. Okay, we can see here they have a various types of the fringe or interference of a fringe patterns on the hard disk or substrate. But the naked eyes, we can see the flatness of this surface is flat, but after we put the what we call that, the optical flat on the top of the surface that we want to measure, they have a various type of fringe. So from that we know the surface is not flat enough because they have a various patterns of the fringe. So from here we can see where is the peak one, where is the bottom. So we have to know the contact point is the peak of the region or section. So this is an example. So okay, this is the one equipment that we will use, which is a monochromatic. I've told you what is mean by the mono and what is mean by the chromatic. So the mono, we only have only one wavelength in order to identify the fringe patterns of that. So this is the setup in order to find the flatness of the surface. Okay, this is a very flat surface, so that comply for three criteria that we already discussed before in terms of a straighten, in terms of a straight. So the fringe straight enough, no curve on that. And then is it a parallel? Yes, parallel each others. And last one is the equidistant. So equidistance mean you have to identify whether this space must be equal for every single design or patterns that we want to. So this is a means by the equidistance. So this is the indicator that saying that the surface are flat when they are comply for the three criteria as stated in the requirements of the fringe patterns. Okay, so this is a principle of reformations. What is a mono? So mono means single wavelength of color. So we already identify in terms of the, because we have a various type of color. With the normal light, basically they have combinations of the various colors. So we use the monochromatic light in order to filter all the others unnecessary light. So only one wavelength penetrate we will penetrate at the optical flat, then we'll give it the fringe patterns on that. So okay, this is how the interference or the calculations, the movement, how in terms of the with they are filtering all the light until they come out with the single light of the wave. Okay, so you have to know this theoretical parts. Okay, and then based on the output, they have like two types of the fringe. So they have a bright fringe, they have a dark fringe. So the white color is more to the bright fringe, and the dark color is the black color is a dark fringe. So what it mean by the fringe, the dark and also the white? So basically is the easy words that we understand is, if a white, the surface is a contact. So that's why if I give you an example at this example here, if not mistake, I already okay, this one E. You can see E, a perfectly flat surface under test is indicated in diagram since the distance are no color fringe. So no more color fringe visible in this surface. So which means they are very perfect. All the surface of the specimen that you want to measure are contact with the optical flat. That's why I say that the B, they have a flat, but of course this maybe the surface roughness is high, so they have like a peak on that. So the peak color is referred to the. I will draw to you later. So I try to connect my tab with this. Hopefully at the end of this class we
velocity
will
and acceleration and
show and ask on this.
first
So
integration, second integration to get you
the
your
white color means, if you see here, the white color of the a bright color or white is referred to the, where is it? Where is the slide even? Okay, okay, okay. The white the white color is referred to the peak surface or contact with the optical flat, and the dark color is referred to the gap. They have some gap on that, so we have the gap will be indicate the dark surface. So I will show to you the example of the video also that give the example of that. Okay. Uh, Here is the, okay, this is a fringe order. For so this is a formula that we will use in order to find the delta L previously. So where is the, okay, this is fringe order, and 0 is a contact. Okay, line of contact means if the first contact or the highest peak of that. So whatever have like white color is a flat, then they have a gap, so they have a lambda on that. That's why they're counted as a number of fringe. So they have a gap, and then closest gap, which means the rough surface roughness is it depends on we affect the surface roughness on that. So okay, that we already discussed. Okay, here. All right. So, in this case, if you want to identify whether the curve of this, they either concave or convex, or they have a slanting slope on that, so we will evaluate it in using this. Okay, for example, if you put the optical flat on the top surface here, we can see the line of the fringe are not equidistant. So we can see they have a slope here, which means it's referred to the they have an incline of the surface on that. So if they have a curve, the fringe pattern will be slightly different. You can see here when they have a slope and they have a large gap, of course their fringe will be closer each others, and then we can see here different pattern if they have a curve on that. And then uh okay, this is an example: straight, parallel, and equidistant surface black. And then if a convex surface, how you will evaluate it, or want to see in terms of the patterns using by the cross sections of this. And then okay, this is an example before and after lapping. So basically the lapping process, or we call that another word, is a polishing. Try to flat the surface. Sometimes they have like a debris was stick on the surface. Even there is a micron level, also it will affect the surface of the surface of that. So that's why after lapping or finishing process, you will see that the fringe is straight compared to the previous process. So if you can see before lapping, they have a light, 5 light bands. When observe that. So after lapping, about 1.5 light bands, or we can see from the surface. So which means we can immediately or instantly identify the performance, the surface, the flatness of the surface. So by using this optical and calculate how good is the surface on that. So in order to to improve the surface, we have to do like a lapping and then finishing, or if the surface are very inclined like this, we will have to sand it first, sanding process, and then once they are meet the flat via the visible naked eyes, then we can see they have a flat enough on that. Then we have to do the polishing. So this is the way that we want to improve the surface flatness of the product or surface work piece. So in this case, also we can see the optical are straight enough on that. Like here, okay, line of contact, straight. That be example for the
Here.
various fringe patterns on that. You can see they have like gaps on it, because it depends on the surface, because it's more to the surface. So the closest and the largest distance of the surface, it depend on the surface. But the technically, when they are comply with the three criteria, it considered as a flat surface on that. They have a three criteria: equidistance, straight, and also parallel each others. Okay, this is the examples regarding on the questions that will be asked, maybe in the test or final exam. So basically, like this. So you have to identify whether these positions are concave or convex position. So point C is at the same distance from the optical flat as point B, because both points are on the same bridge. So you can see here point C here, okay, and also B, because they, they are a same fringe pattern here, so it will consider as a same distance from the optical flat, because they're same height or distance for that, so because they are aligned in the same fringe. However, different of a distance from the optical flat of a point C here and D is about half lambda. So because if you can see from the previous formula, uh, each gap for its fringe is about half lambda. So therefore, point C is lower than point D. Point C is lower than point D. Hence, the surface is convex. So they have like a, you have to see where is the contact point. So in this case, the RR is a contact point. So why we say that, they have like a slanting. Contact point is the highest point, then they have the slanting like this. So you can see here, example for the concave. So you can see here, example like this. What is it? Okay, here. So the A is a contact. You can see they are moving like this. So they have a concave positions on this. So same goes to this here. You can see also here, and then they will be like this. So if this D higher than C and B, so which means the curve is like this. Okay, this is a cross section here. So this is the D. How difficult to do that? Oh my god. D, and this is a C in the cross section. So you can, I hope that you can understand it. So this is the slanting, because this is a contact point here. Contact is almost at the highest point of the surface. Okay, how about this? Okay, you can see they have like a D and C. So there is a D here, and then this is a C, and this is a B. Of course, this one, C and B in the same fringe, they have like the same position, and D is slightly higher than the C and B. So the concave, this is a concave. Concave is like this, and convex is like this. So you have to identify it, the patterns of this. Okay, right. How about this? Okay, you can see if like this, C is higher than D. You can see D here. This is a concave. Concave. They have like a cup, something like that. So this is the line, the bottom, and then this is a peak, the highest one. So if you see the reference is like this, so they have a opposite from the concave. So of course this is concave, right? Right. So in this case, how is the pattern look like? So they have three cross sections that we can observe here. For the first one, maybe like AA. So you just straight away see from this view. So where is the reference? So the reference is like this. So supposedly is like a convex. Okay. So this is a reference and this is a patterns look like. Of course they have. So how about BB? BB is along the cross section. Of course it's straight lah, because the distance are equidistance. So which means they have a flat flat surface. If you do a crossing event, they have like a curve, but the curve is in what positions? You have to see in terms of a cross section. How about C? So the C section cross sections must be a bit slanting. I mean the it's not too concave, because you can see the fringe patterns what you call that, almost a straight, so but they still have like a curve here, but it's a very minimum curve. So the cross section must be slightly I mean just compared to this section AA, of course they have like a very, you have to see the difference between the both cross sections. Okay, how about this? Okay, so this is the same as before. You can see they have where is the reference? So you have to find where is the reference. So if you can see the reference, R is referred to the contact. So flat at centers, drop at the edge. So you can see they have edge. So they're flat at the center here. Here they have a flat surface because they have like a what we call it straight line, and then at the end they have like a edge. So it's a very straightforward actually. So how about this? Even they have like a fringe, is it comply with the all requirement? I mean the three requirement in equidistant, straight, and also parallel. If yes, it should be whatever fringe angles. So depend, if you comply with the three criteria, the surface will be flat enough. So all the edge is straight. Okay. This is another example that you have to think. So if okay, uh, this I mean this contour, we call it contour. Which this is the contours that normally have to imagine in terms of a 2D to a 3D. So if you know this is a for example, if this is a reference here, okay, R means the contact point. If I told you R mean reference, which is contact point, which is the highest point of the flat. So if the surface, the contact point is always the etc. Contact point is always the highest point of the surface. You have to know that. Okay. So in this case, they have a 2 point here because they have a 2 reference or R value here. So you have to know in this case for section AA how is it supposed to be. So in this case you can see this is the highest one, but the design will be dropped a bit here. Same goes to this, the design also will be dropped here to this direction. Okay, so you have to make, they have like a curve on the top. If you see at the cross section E, so they have like a peak, and then they have like a, so which peak that highest each other? Is it from this cross section? We can see that this peak is higher from this peak. Okay, and see this not straight. Okay, they have still a gap here. So why? Because these cross sections are not go to this fringe. If the cross section is like this, maybe the peak is the highest. So you have to just to see the calculations of the fringe. You have to calculate from here 0, 1, 2, 0, 1, 2, 3. So they have a 3 at the left side here. So you have a something here, and then they will take up back after for this one. So you have to have a good imaginary in terms of the 3D view of that. So uh, this is a measurement of a parallelism of a block gauge, and then the types that we use in order to measure the flatness of the surface. Okay, for the calibrations, also you use a parallelism block gauge. So this is very perfect, have supplied by the suppliers. They do with the very precise instruments. So you have like a we call that the optical flag. You put in the parallelism of block gauge, so we can see there maybe like a very several fringe, or maybe not have any fringe on that. Right. So measurement of a parallelism of block gauge. Okay. At the same time, in these sections we want to know. Okay, at the previous sections you are measuring the straightness or the flatness. Okay, next here, today we will continue about the parallelism. So we need to compare in terms of the parallelism of the block with the specimen, either it parallel each other or not. Okay, so this is the examples that we can see here. They have reference block gauge and the test block gauge. So, and then we put the optical flags on the top. So from the optical flag we can see they have a difference, I mean, in terms of the fringe patterns. If I told you the fringe pattern at the left side here, okay, this is a very reference block, which is a perfect one. See here, fringe pattern, and then a very call that small gap. And then when we compare with this test block, they have like a slanting here. Of course, they have air gap here to fill to fulfill here. So that's why they give like a patterns, and also they have a curve, a big curve on that. So that is a comparison in terms of a parallelism. So next we go to the this. So they have a half fringe on that. You can see in terms of the parallelism, also we can identify using the optical flag. So grade 2 explore a fringe. Okay. Okay, in this example here we can see the non-parallelism along the x-axis. So you have to know this axis in terms of it. This is a standard, I mean, three flaming hands or something like that. So x, y, z. So this is the x direction. So the reference, of course, at this x directions, and in terms of the height is a z direction, and if from the movement from the reference to the backward is a x direction. So in terms of non-parallelism, we can just calculate using the number of fringe given here. We can see and use this formula, and lambda also will be given in the equations later. So for the reference block, they have like about 5 fringe, and for the test piece or test block, we have about 7 fringe. So you have to what you call that, to measure it by minus using this formula, which is the test block minus the reference block, about 5 fringe, and then times lambda over 2, because from this here you can see they have like a one gap fringe is about half lambda. So this is the standard formula given. So normally lambda will be given according to the light source that you will use in the monochromatic light machines. How about this example? So in this case, their block is not parallel in between the test block. So we just measure at the Z direction. So how about this? So they have a different in terms of X directions and also Z direction. So they have like a different with the two axes here. Of course, you will identify uh, the parallel along X and Y X axis. So they have like a difference in terms of Z. So you can see by calculate using the number of fringe. So of course the test block is always a straight. You can see perfect the five numbers of a fringe here. And how about the test block? So the test block is about angle here and also the number of fringe are slightly different between this. So the height also we can identify from here, delta AB and also delta AC. So the delta means the difference between the A to point C, A to point B. So they have a two axis difference of that. Okay, why is this? Okay. Okay, this is examples of the activities that I want you guys to submit at the end of this class. So I will guide also you guys to do that. Hopefully, yeah, for the cross section you have to do like what I call that the cross sections you have to show and also the the calculations of the lambda also you have to use all the familiar givens in the sketch. So in this case, you have to use all these formulas that given in this. So I told you before that the wavelength will be given and you have to count the number of fringe in order. So what is the questions once you guys do is figure one show the fringe pattern produced on the surface. Point A and point B represent the contact between the optical flat and the surface. So you have a two contact point, the same as a previous example I told you. So sketch a cross sections along the x dot x and y dash y. So same goes to this example. I think you have to imagine it how it's supposed to be like. Okay. Where is it? Yeah, same like. So they have an example given here. Where is it? Then, yeah. So you have to imagine it. So most probably you maybe the answer will be same or different. So it depends on the number of fringe. So you have to see how you will identify the number of fringe for the contact A and contact B. So of course, the contact point is zero, the higher one. But you understand this one. You have to imagine it. So of course, uh, I will give an example according to this, of course. So hopefully this one, you will understand it. So let me try to connect my tab. Hold on, moment. Okay, they want to sketch the cross sections and then hence estimate the difference in height between the highest and the lowest point along the y given the wavelength used is 0.585. So the wavelength already now you have to identify along the x at what is the highest and the lowest fringe. That's it. You have to know the number of fringe. So it's a very straightforward actually. I will give you an example on that. But you have to solve these activities. So actually they have like two activities here. You need to submit it individuals. I believe they have in your we call that in your slide, of course. So I will explain every single activity here. So let we go to the activity pool before I just go to the example. Hopefully I can connect it. Okay, so in order to find the estimate the difference of height, so you have to calculate the number of fringe. So have to start. So along this x axis, how many fringe they have starting from the contact point. So I already tell you how to measure the fringe. So the contact is a this is same like this. You can see here. Where is this one here? Okay, it's like this. See? So this is a fringe number one. Where is n one, two, and three, and four? So they have a four fringe here. You can see. So you have to minus the peak one. So the difference is the of course the zero minus one, something like that. So this is the way how you may calculate the fringe, and you will able to identify the the delta or the difference in terms of height according to the questions will be asked here. So different in height, so you have to know along the cross sections how many fringe that involve in your calculations or cross section here. So in this case, for the x cross section might be different, of course. So in this case, they want to know about along the section YY. So in this case, in the XX cross sections, the fringe involved here is fringe number 1, 2, 3, and then this is one, one, two, three. So it depends on the. I will show to you. Okay, I already joined. All right. Okay, next we go to the second activity here. Okay, in the test of aphorisms, the fringe patterns on the grade 0 and grade 2 block were compared. So you can see they have a grade 0 and the grade A, grade 2. So this is of course the test piece and also the standard block, same like this. You can see here, they have like a reference gauge block and also a test block grade 2. So see 0 and 2. So which is a 0, which is a 2? Of course, 0 is the left side and then the 2 is the right side. So the fringe pattern obtained shown in the figure A, okay, if the wavelength of the light used is a 0.8 is 0.585, determine the difference between the height. Number one is a point A to point B. So if it have a difference in terms of a height, you have to calculate it and see. Okay, in the back. So it's up to you then. You have to try to do it because I will show to you later the example here. So number two is a point B, point C. Does it have any difference in terms of height? So if not, you have to justify it why. Since they have the same fringe, they have no difference on it. So if the optical flat rotate at the fringe pattern produced on the grade 0 block as shown in figure B, okay, the 0 rotate, they have rotate 90 degree on that. Shown in figure B, sketch a fringe pattern that may observe on the grade 2 block gauge. Okay, all right. So I have a lot of chat here. Oh, you need some time to understand the practice. Okay, it's okay. I will give you time. You may be submit individual in terms of answer letter. explain how to imagine it. So no problem. I will show to you. But okay, I will allow you to send this activity until Sunday. So Monday will be have the five. So of course, I will count it later if as a mark. So you have to try, and I also we have a time until 12. We stop just a bit, and then we continue with the chapter 3. So no worries about that. So you have to understand. I just give the overview regarding on this activity, how to to answer it, but at the same time, I will show to others examples so that can know how to imagine it in terms of uh, for like all of course. So doesn't matter. So I just want to explain it first in order to make sure that you have an idea to answer these two activities given here. Of course, you have to submit, and I will consider as a marks. Maybe it's as a part of the assignments like that. So they have a assignment before in terms of the grouping assignment, but now I want you guys to send it by individually. So the assignment I will consider also, and the quiz is already one quiz that you have done before, and test. Yeah, they have another section later. So in this topic, I will give you an example because I connect it with the I will draw it to you in order to make like clear on this. Okay, so for the activity 5, it's a very straightforward. You have to use the formulas given in this uh I mean in terms of the lambda to the work piece minus the reference piece and times lambda over that's it. That is the idea how you want to say. Things is for the questions questions if the optical flat rotate, so you have to imagine it. So if the rotate from the this isn't to this center, they have like a three frequency. So how about the grade 2? If you rotate, is it the same or not? So you have to imagine it. So that is the ideas on it. So okay, I will allow you to send this activity until Sunday 12 o'clock. So if Monday I not consider the submissions. So for on Monday we will discuss it in terms of the answer for this. Okay, hopefully. Okay, so I will uncheck it. So I try to give you an example. Monday public holiday. Is it Wesak? Oh my god. Wesak ah? Okay. I forget already. Okay, so it's Wesak Day that we have to cover the topic 5 on a Thursday. And if not finish, I will do a recorded video in order to you and refer for the complete of the I mean sessions of this. Okay, no problem. So we still have time next. So and let me discuss it regarding on this. So and I share first. Hmm. Oh, the project I will explain after this. When we start this topic 5, and then 15 minutes before the class end, I will explain the project and uh, start and discuss with your group. Okay. Can you guys see the screen, is it? Okay, good. Alright, for example, right, this is example. Okay, you can see here, this is a contact, which is a peak one. Okay, this is a contact, which means the cross section here, we can see, we can see from this side. Can you guys hear me? See, can I? Okay, this is a cross section AA. So supposedly this is a peak. As I told you, this is the highest. Okay, and then this is the lowest. So the cross section is should be like this. From here, here is the lowest, so it should be like this. Okay. Until now, you can imagine how the supposed to be the example. Okay, this can. Okay, I will explain you the simple one, but in application you have to think by yourself. Okay, now we go to the convex. Okay, this is a concave. Sorry, this is a convex. Sorry. Convex mean they have a bumping on that. Okay. If I give an actual situation, how can I ask you in the exam or something like that? So this is the way how I practically apply in the actual applications. Okay. So now we clear enough on this. So how about this example? Okay. Slightly same, but so this is a contact point. It's a contact point. Already masuk. Uh, how about this? Okay. Essay or no? I don't know. This is a very straightforward. I don't want to mark a lot of essay writing. Of course, I just want to make sure you may understand how to read the article and come up with the sketch on it. So this one, the cross section contact the same height of this. It's same or not, we have to calculate the number of fringe. This is the same number of fringe here. This is a center. I mean, this is another one. You can. It has a different border on this. You can see they have a one region, two region, three region. Okay, so you have to evaluate it for this part. For the region number one, they have like a 0, 1, 2. Region number one, they have a 2 range, is it? So how about region number three? Zeros, 1, 2, 3. They have a 3. So definitely the region 3 is higher than the region 1. So if I want you to do a cross section like this, definitely the drawing should be like this. They have like a mesh. So of course they have like a slanting here. This one contact. This one is a second contact. Okay. So you have to see this one is a 0. This is a this one. So this is a region 3, region 1, region 2, and region 1. So for this one, you guys understand or not? I just give the answer already. So hopefully you can score all the sake. All right. So enough for this. So
Doctor, I have a question.
yeah,
Why is it region 3 to 1 and not region 1 to 3?
because I start for this, the highest one. See why I'm saying that the region 3 is the highest? Because they have a lot number of fringe here. So they have a 3 number of fringe from here is 1, 2, 3. It's only 1, 0, 1, 2. This is another, it's a slanting at the curve here. So we never count the because maybe the signal or that cannot be counted as a, that's why you have to identify when you have to see the questions, then you must imagine it how the regions are supposed to be like. Okay. So for these conversations, of course you have to think by yourself lah. I cannot give because you have to think about it. So that's why you already know in terms of these cross sections, you already can imagine it, the peak and the lowest one. Okay. What else for the activity
Uh,
5?
Doctor.
Yep.
No, my question is why is it region 321, not 123? Because based on what we're seeing, it should be region 1 at the left hand side and then region 3 at the right hand side, right? Based on the diagram and based on how the cross section is.
Oh, you mean here because I start from here, so I just go like this, go like this. So oh, okay. Thanks. Who's correct me? Oh, it's supposed to be region 1. Okay, 3 here. Yeah, you are correct. So see, you already can imagine. So yeah, definitely yes. You have to do like this. Then you move like this. Have like cross section this. Okay, this is a region that you have to talk about in terms of cross section. So, for example, in this case, this is a region 3. Is it region 3 here? Okay. Yeah, you are correct. Region 3. Okay, region 1, region 2, and this one the region 1. Is it? Is it? Who say that? Is it Mahesh or what? Mahesh, you are saying what?
Yeah, sorry, yeah, correct.
Oh, okay. So yeah. Thanks for correcting me. You are right. Yeah, definitely. You straight away move it into a this directions to make it clear. So the region 3 is the right side, and then the region 1 is the left side. Possibly. All right. So if like this, then you have to see another way around lah. So they have a different. Okay, it depends on the where is the directions given by the questions here. So in this case, you can see in the activity 4, they have a directions at the what call that left direction, right side. So you have to follow it. Okay. Okay. So you have to follow. If this direction, you have to move like this and move like this. That is the uh, you have to be careful on this. Okay.
Doctor, just want to confirm. So the region with more fringes, example like 0, 1, 2, 3 compared to 0, 1, 2. That means the one with 3 fringes are higher than the 0, 1, 2. That means to be
Yeah.
taller. The peak will be taller
Yeah.
than
Yeah.
the lower region. Lah. Okay, thank you, doctor.
Yeah. You can see the example given. I think from the slide number. I'm not sure. Okay, slide number 55. Is it same as you? 55 slide. You can see they have like the different. They have any different. So, all right. In this case, they only have two regions. Okay. Can you guys see the example here? How can I view it? Hold on. How to stop sharing? Yeah. Okay. Hopefully it will help you. Okay. Can you guys see this? I can draw. I cannot draw because it's very difficult. Okay. Can see here they only have like two region here because this region is under this. Okay, they have a two region here, which is here one. This is two. Okay, that's why you can see from here is definitely this one. Okay, hold on. I want to see first. 1, 2, 3. 1, 2, 3. 1, 2. Okay, hold on. Okay, right. This one is supposed to be 1, 2, 1, 2, 3. It looks like this regions is supposed to be like this. Okay, I got already. Where is it? Slide number 55. All right. Okay, this one. Okay, this region is supposed to be like this. Then this region like this. Okay, they have a two region here. Finally, this is a first region, this is the second region. So we have to identify in terms of the height based on the number of fringe here. Okay. So in this case, this center of this, okay, this is the center. They have a lowest point here. Okay. So which means these regions, one, two. Supposedly they have a same height. Okay. So maybe this image, I will correct it. They supposed to have a same height. It depends on the number of fringe. Okay. So in the example given here, in the activity, you have to identify it. Of course, they have a two region here. This one have one, two, three. This is one. This is a two. This is a three. This is a one, two, three, four. Okay, these are different. So they have a two region separate, and of course, the middle is the lowest one. Okay, so you have to identify it according to the number of each or regions or something like that. Say okay. So in this case, uh, you have to imagine whether the the y will be go to the contact point A or not. So that is the tricky line. Of course, you have to. So you have to know uh, the pattern should be increase a bit or not, or just a slanting like this. Or you got what I mean. So the thing is you have to know whether this is like this or like this, or you have this or like this, turun bawah. So you have to know it. In front sections follow the error. Can't understand, Tanzi. So can you explain to me? Or after a long holiday, you cannot absorb the too fast, huh? Imaging shape is hard. Okay. So I see the questions from the YY. So from the NZ, in front section view is follow the arrow. In front section view, I cannot understand the equations, Tanzi. Can you explain it to me? How is it supposed to be? Arrow YY is it follow the front? So you have to follow whatever arrow that, like for example, if the question want to see from this side, so as Mahesh asked me previously, tell me previously, the region might be slightly different in terms of left or right, depend on the questions. So maybe for this one, the if you declare the contact point B at the left side, of course we go to the contact B is the left right side. If the error is moved to the right side, the contact B is supposed to be at the left side. So depends on the errors of the cross section that you want to observe. That is the way. This is one of the capability for you to understand and imagine it, how the content is supposed to be. Okay. All right. Okay, I think I will share to you a video first before we go for the before we go to the next topics. Okay, hopefully this topic like easy to understand. Maybe you have to. I already shared to you guys also a few YouTube's video for your reference so that you can see the details on the uh, explanations on that, and or else you can ask me straight away of verification of answering the question. I will advise you, but you have to come out with the solutions in order to identify whether it answering your questions or not. So you can refer the previous past year's questions also in order to see the example question. So it's nothing different, nothing much difference between the previous, the past year questions with the incoming questions. Also, you have to refer the previous one also in terms of the accelerometer calculation. So I try to answer to ask, not exactly as, but of course I will change it a bit on that. So you can refer the past year and do a lot of exercise on it so that you can have an ideas on that. Okay. I will share with you the video first.
Doctor, sorry. Yeah,
Yep.
you don't need to share screen. I think everyone can just see through the slide. For slide 52, you were telling there was a
Mm-hmm.
mistake, right? That means the on from the left hand side of the B to B card, it should be lower, is it, or higher for the peak?
Same height. Same height.
Same height, because the number
Which
of
one? Which
regions
one?
the both regions are same.
Which sorry, is it
Slide
from?
52, the one with the like similar to
Okay,
the
let
activity that
me
the doctor gave.
yeah, let me share first, because your slide is different with me, I think. This
Oh,
one you mean?
yes.
Is it? Okay. So I told you, supposedly the number of fringe, wait, let me count it first. Is it one, two, three, uh, four, six, eight. Oh, okay. Supposedly they have different because they only have a two region here. Okay, let me correct it back. Sorry, where is it? 552. Okay, one. Okay, you can see this one fringe is move towards this region. See this contact at this region. So you have to count. Uh, if this is 0, 1, 1, 2, 3, 4. Okay, they have a 4 fringe at the top one. Okay, this one, 2, 3. Okay, this is a different number of fringe here. So definitely, the larger number of fringe is slightly higher. Okay, compared to the other side. So you have to see the directions of the, cross sections, whether this one. So for this, I think it's like a mirror. It's wrong because supposedly here, suppose at this region, this one is at this region. Dia macam mirror lah. This is a mirror image. Supposedly dia terbalik sikit lah yang ni. So you have to correct it. Okay. So as I told you, that's why I'm not concerned. Before this, I not notice about the directions in terms of a cross section. So if you go like this, and then like this, you can see this one is lower. The right is lower than the left is lower than the right. So only this image should be like mirror image. You have to swipe it. Okay. Is it answering your question, Mai? Dia terbalik dari segi dia punya cross section ni saja. So you have to make it a correction on it lah.
So basically, just
Because
take the cut image and flip it.
yeah, I mean swap the version because the top one here supposedly higher because there's number of fringe difference. Okay, so you can how can I just how to correct it? So
No, I understand, doctor. It means take the image,
supposedly like this.
take it and then flip it on it. Understand? Just basically put beside the mirror and flip.
Flip. You have to flip. You flip by yourself. Mirror.
But
Supposedly like
doctor,
this.
I have another question. So how? So I have to analyze properly.
Yeah. Sorry.
So sorry, doctor.
Sorry.
That's how got interruptions. Anyway, so basically, to understand like which part of the fringe is connecting to which peak, we have to see the curve lah. So if it's curving towards one
Yeah,
side, that
curve.
means it's part of that region. But then
Yeah. If
to
the
separate
if
the
the
region
if the
is where
fringe
there's
are
a straight line, right?
straight line is another region. So of course you have
Okay.
to, if the curve towards the point should be like this region on that lah. Yeah, the region because they have the point. Okay.
Okay, I understand. The middle line for this image is like, if first is at the start it will be curving towards the top part, but then at the bottom it's curving towards the bottom. So can we say that's the another region or it's part of the top region still?
It's a part of, I mean, it's only, you have to count how much a reference point in the surface. So if the two, definitely they have a two regions. If they have like a straight fringe, that straight fringe in another, independently it's gonna refer to the which the ones. That's why you have to be careful on that. If the center, for example, for this one, the center fringe are straight, you can see a straight now, very straight, then it's independently. It cannot belongs to the point A or point B. So this is the independently. So that's why in the example given in the tab previously, it's independently. So that's why I declare as a straight line. Not belongs to the first point or second point. Okay.
Okay, so for this case, this is like a straight line, so we don't include it into any region, part of the region lah. So it's like a separate region itself.
Which one? This one.
Yeah,
In this case, they are belong to the top one. The
top one. Okay.
belong to this region. You can see here. So that's why these regions are slightly higher compared to the second point. For example, if I told you this is a point A must be higher than point B. So that is a way how you want to 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 draw lah the cross section. So this is a point A. Supposedly this is a point A. This is a point B. Okay. So I have a question. I can see a question. But the center fringe on top or bottom? But the center fringe is from the top or bottom? Why? I'm sure your questions. Aiman. Can you just turn on your mic and asking straight away?
Hello, Doctor. Can you hear
Yeah.
me?
Sure. Can.
My name is Aiman.
Mm-hmm.
Same like Mahesh. So, on how do we determine the center fringe? For this case, is it the curve for the fringe is more for the top region or for the bottom region?
Okay. These questions, I think I already answered it because it depends on the curve. If the curve is towards the bottom, the top one, you have to consider as the top. If the curve is more to the bottom, then you have to go to the bottoms regions on it. So that is the way how you want to identify it, whether your number of fringe must be counted from the which contact points. Okay. And then in other case, if the suddenly you can see the line is a straight now, so it's independently, it's not belongs to the top uh, group of fringe or bottoms group of fringe, if in this case. So maybe they are not counted, and supposedly the number of fringe if same, then the height will be same lah. That is a way how you want to identify it in terms of a flatness of the. So is it answering your question, Simon?
Clear, Doctor. But for this case, I think it looks a bit similar for both top and bottom region. So, can Doctor clip the center fringe?
Okay.
Just yeah.
Let's see.
Sorry, Doctor.
It's okay. It's okay. How is it supposed to be? Aku ni dah macam ada conteng kan, so I cannot clearly say. I don't know whether I see the other slide. Hopefully that I can this. Alright. Okay, let me check whether it is under. Is it this one under? This is a clean version of this. So hopefully we'll see 50. Oh, which is like it. All right. Okay. Let me see. Looks like the same, is it? Okay. Wait. There 1, 2. Curve. Oh, okay. Now I got your point already. So they have like a curve here. Okay, they have a curve here. It's belong to this regions. Suddenly they are changed. The curve be like this, is it? All right. So definitely this is an independence lah. So of course we cannot see in clearly with parts or region of this. So in this case you have to divide it into a T, and definitely they have like a 1, 3. So 1, 2, 3. Okay, so supposedly they have like a same height on this. The height is the same. That's it. So is it answering your questions or not? Because okay, the way how we want to identify whether the center of the fringe are independent list or not. So that is the way we want to. They have like the curve inside. So in this case, maybe we can put it as an independent because have a curve here. Sometimes a curve here, and then suddenly they are dropped like this. So this belongs to this also. So we have a region. Then we put under the centers or state regions on this. Unless if the image is clearly like this, they have a curve here, so you have to count it. For example, in this activity, so they have like a clearly versions on that, so you can see from here also I can see the regions. So that they don't have any center regions here. So for the example given here, maybe like a tricky or something like that. This is a way how we can classify it to a state regions on this. Okay, so in this case, I agree with Aiman. So they have independence, and the height for the first peak and the second peak is supposed to be same lah, same level. So this one and this one, you have to a bit increase, and then down it back. Okay, so hopefully you guys can clear isn't it? So you have to determine whether the center points are independently or towards the top or bottom. So you have to differentiate. So hopefully you can imagine it. So try to find another exercise so you can do by yourself, and you may ask me straight away, or even some of you guys also send to me the questions that I will ask in the class using the email. So I try to explain it later. Maybe I not reply it straight away, but I will call you, and so I will explain it how to answer these questions properly. Okay, so no worries about this. So you have time to digest and try to find various cases so that we have a discussion on it. Okay, so the basic thing is you have to know how to identify the peak point and the low point. That is the main objective of this understanding or learning outcomes of this. Okay, so we stop 5 minutes. Yeah, I promise you to show the videos. Hopefully we have like 8 minutes videos in order before we start. I think we not start the topic 5 today, maybe the next week. So I will brief to you about 15 minutes the regarding on the project that we will do here. Okay.
Measuring the surface roughness or surface flatness by using a monochromatic light source. This is one of the very precision method where we are going to get the flatness error in terms of the light source, that is a monochromatic light source. Here we are using optical flats. In that light band reading through the optical flats using monochromatic light. So that is what the source we are using here. Okay. So these are the optical flats. So see here, this is one of the optical flats. That is a flat surface, and this is made to be in conjunction with this slip gauges. Why we are using slip gauges? Because slip gauges are having a very flat surface and even a polished surface. Here, whatever the surfaces we are using, two surfaces, they should be polished to a very high accurate. There is a mirror finish. Okay. Here we are using three types of optical flats. This is made out of quartz. So this is a flat optical flat. This is convex and this is concave. Okay. By using this, we are going to have a light bandwidth as well as dark bandwidth. Now, in this one, you see the basic principle is, so it is shown here. So let us see here, this is what the optical flat, and this is placed on the flat surface. Here we are differentiating the surfaces with the optical flats. Right? For example, here the optical flats, if it is placed on the surface to be tested, it is going to make a wedge here. Just see here, one ray is entering here at A, and partly it is transmitted through AB. And partly it is reflected back in this one B, C, and here this will go out of the optical flat. Okay. Afterwards, you see the same ray, some part is transmitted from B to D, and again D to E, and again E to F. If these two rays are in phase, a bright band will be seen. Again, you see here one more ray is there. That is from G. The ray G is partly transmitted to H. And from there partly reflected back, it is Hj, and the same ray is partly transmitted to Hk, and then again it will be reflected back. If these two rays are in out of phase, there will be dark bands are seen. So we are counting the dark band, measure the surface roughness. Here you see when the bright band will be seen and when the dark band will be seen. That is what the one of the concept here. The difference between the lengths of the paths taken by the two rays BD plus DE, and if this distance is even number of half the wavelength, then the rays will be in phase and bright band will be seen. If the two rays, the path difference between these two rays are odd number of half the wavelength of this particular monochromatic light, then they will be out of phase, then dark band will be seen. You see here three different surfaces are shown here. This is a flat surface where we are going to get the fringes in the straight lines. They are very parallel to each other. Like the same way here, convex surface is there. We have made this as a convex, the optical flat, and here it is a concave. In the convex, you see, I will show it here clearly. You see, in the concave here, so at the center, there is no contact between the two surfaces. There is a bright band will be seen. Afterwards, it is followed by dark circles. So this is the convex, where at the center it will have a contact. It will be a dark band and followed by circular dark bands. So convex and concave. You see, as here we are not using the larger surfaces, the surfaces will be like this way. So this is the optical flat, below which we have used the slip gauge. And if you see from the top, this is the flat surface, straight surface, where the dark bands are seen like this way, parallel straight lines. And in this one, concave surface, the dark bands are seen in the curvature. As there is a very limited surface, we can't able to see the circles here. Here this is the convex, here also we are going to see a, curved lines, okay. And by counting this dark fringes, and then, so we know the lambda of this particular monochromatic light, and multiplying number of fringes with lambda by 2, we are going to get the flatness error of this one. Now let us see here, this is what the lambda is the wavelength of this monochromatic light source. It is a standard, okay, which is given by the designer, okay. You see here, for the flat surface, flatness error is equal to, now let us see here, let us count the number of dark fringes here. See, alright, we have to adjust it so that we are going to get maximum number of fringes. Alright, just see here, 1, 2, 3, 4, 5, 6, 7 fringes are seen here. All the fringes are in straight line and they are parallel to each other. Now 7 into lambda by 2. Already I have written lambda by 2 here. 7 into that much. Now just find out that one. That will give you the flatness error. Point 0.0001847. 0.0001487 into 7. That is C. 0.0010409. 0.0010409 mm, because lambda is given in mm. Now flatness error of concave surface. You see here, this is what the concave. So how many fringes are shown here? There 1, 2, 3, 4, 5. 5 fringes are visible there. We have to multiply 5 into the lambda by 2. Then we are going to get the so flatness error 0.0001487 into 5. So that is 5.000435 mm. Like the same way for convex surface, 1, 2, 3, 4. 4 fringes are seen here, dark bands. So that is 4 into 0.0001487. That will be 4 into 0.0001487. So that is 0.0005948. 4.0005948 mm. This is the flatness error of convex surface. By this way, we can able to get the flatness error of different surfaces. So this is the tabular column where some students has done this one. For straight surface or flat surface, and this is the concave, convex, number of fringes, flatness error is there. Remark on the surface, that's what I have written here. So this is what. So for this one, straight lines will be seen, and for this, the curved surfaces, again for this also. Because as the surface is limited, we are going to see the dark bands only in this way only. So this is about a very simple way of getting the flatness error of different surfaces by using optical flats in conjunction with some good quality surfaces. That is, here we have taken slip edges. Okay, thank you all.
Okay, we take about 5 minutes break. I just want to wash my washroom, then we continue back in within 5 minutes time. Okay, so have a question. I will say later. Okay.